press the bell icon on the YouTube app and never miss another update.
Hello students, welcome back. This is a discussion session regarding D and F block elements. So after completion of the content, I would like to discuss some important questions and some previous questions which are belongs to D and F block elements. So stay with us, stay safe, and read NCERT and improve your skills. Apply the skills to solve more number of questions, then you will get a good rank in first attempt. Clear? So the topic name is D and F block elements. The D and F block elements. So from that, question number 3. Reaction of KMnO4 in neutral or very weakly alkaline solution can be represented as. 4 options was given. Already we know, already we done some chemical reactions regarding potassium permanganate. Potassium permanganate is act as a strong oxidizing agent in acidic medium and alkaline medium as well as in basic medium. So question number 3, MnO4 minus plus 5H plus 8H plus 5 electrons gives rise to Mn2 plus 4H2O. This is for acidic medium. When reaction takes place in acidic medium, permanganate MnO4 minus required 5 electrons. What will be the conversion? MnO4 minus is converted to Mn2 plus. MnO4 minus is converted into Mn2 plus. If the same reaction takes place in alkaline medium or neutral medium, then permanganate MnO4 minus gives rise to MnO2. MnO4 minus gives rise to MnO2. On addition with what we will get here, plus 2H2O, here plus 4OH minus, and here number of electrons 3 electrons. This reaction MnO4 minus plus 2H2O plus 3 electrons gives rise to MnO2 plus 4OH minus. This reaction favors in alkaline medium or neutral medium. Actually 3 reactions are there. One is MnO4 minus gives rise to Mn2 plus. Second one is MnO4 minus gives rise to MnO2. Third one is MnO4 minus gives rise to MnO4 2 minus. 3 reactions are there. So according to our question, very weakly alkaline solution or neutral. Very weakly alkaline is nothing but neutral solution only. Neutral or very weakly alkaline, what we will get? MnO4 minus plus 2H2O plus 3 electrons gives rise to MnO2 plus 4OH minus. This is a standard and branded equations. These two are very, very important balanced equations, balanced half reactions. This reaction option C is acidic medium, option 1 is alkaline medium or very weakly alkaline medium or neutral medium. So make a note, my dear students, the answer is first option for the question number 3. For the question number 3, option number 1 is the right answer, and the next one is question number 4. Question number 4 is a concept oriented, conceptual question, that is if you should read thorough that concept regarding actinides and lanthanides, we have to find the answer easily. The electronic configuration of actinides cannot be assigned with degree of certainty because of. Already we discussed in the theory class. Already actinides, what will be the configuration? Actinides 4F, sorry, question number 4. So actinides configuration, already we know that 7S, 6D, 5F. 7S, 6D, 5F. 7S is outermost. While coming to 6D and 5F, what are the N plus L values? N plus L values for 6D. 6D N plus L value is equals to 6 plus 2 is equals to 8, and 5F N plus value is equals to 5 plus 3 is equals to 8. N plus L values of 6D and 5F both are nearly both are same values here. 8, 8. N plus L values of 6D configuration and 5F configuration both are same, and 7S configuration N plus L value also same. 7S. What is 7S? 7 plus 0 is 7 plus 0 is equals to 7. So, for S orbital, we know that S, P, D, F 0, 1, 2, 3. For S orbital n value 0, for P orbital 1, D orbital 2, F orbital 3. So 7s, 7 plus 0, 5f 6d. See this 5f 6d n plus L value. So 6d means 6 plus 2, 5f means 5 plus 3. So n plus L values are same. So what will be the reason? What the electronic configuration of actinides cannot be assigned with a degree of certainty? Because of the option 1, simply you should go through that option 1, small energy difference between 5f and 6d level. Small energy difference between 5f and 6d level. 5f 8 value was there, 6d 8 value was there, but principal quantum number 5 is less. So make a note, this was very important. Energy gaps of outermost electronic configurations are very small due to the small energy differences between 5f and 6d levels, and the actinides cannot be assigned with a degree of certainty. So question number 4, the option is first option is right for question number 4, and the next one is question number 5. Question number 5 is when KMnO4 react with acidified FeSO4. KMnO4 react with acidified FeSO4. What will be the options? FeSO4 is oxidized and KMnO4 is reduced. Only KMnO4 is oxidized. Only FeSO4 is oxidized. None of the above. So simply already we done this equation. KMnO4 minus, already we know MnO4 minus plus 8H plus 5 electrons gives rise to Mn2 plus 4H2O, and Fe2 plus gives rise to Fe3 plus electron. Ferrous salts oxidized to ferric salts. Ferrous salts oxidized to ferric salts. Option 1, see that FeSO4 is oxidized. FeSO4 is oxidized. And multiply with this equation with 5, suppose. Multiply the equation to 5, suppose, because of in equation number 1 5 electrons are there. Equation number 2 only 1 electron is there. Because already I said it is a branded equation, this is brand or standard equation of reduction of reaction it is. And multiply with 5, what we will get? MnO4 minus plus 5Fe2 plus 8H plus 8H plus gives rise to, what we will get here? Mn2 plus 5Fe3 plus 4H2O. Here oxidation state of iron plus 2, oxidation of iron is plus 3, and oxidation of manganese plus 7, oxidation state of manganese plus 2. Plus 7 to plus 2 decreases, plus 2 to plus 3 increases. Decreases means reduction reaction, increases means oxidation reaction. So according to this information, what the option we have to select from that options? When KMnO4 react with acidified FeSO4, when KMnO4 reacts with acidified FeSO4, FeSO4 is oxidized, ferrous salts are oxidized to ferric salts. Ferrous salts are oxidized to ferric salts. Potassium permanganate reduced to what? Mn2 plus. Potassium permanganate reduced to Mn2 plus. So option number 1 is right option for the question number 5 according to the chemical balancing equation, and followed by that question number 6. Question number 6 is match the following. Already this is useful for uses of transition elements. Transition elements are used in different streams, in catalytic stream, in or about that in medical stream, different type of industrial stream, and we have to prepare batteries, different type of examples we discussed in that synopsis classes. And so match the following. Column 1, column 2 was given. Electrical industry, we know that electrical industry we can use copper. Electrical industry, what will be the answer is copper. Simple it is. Electrical industry, the answer is copper. Second one is batteries. We know batteries, we can use that zinc. Batteries is zinc. The answer is zinc. And next one is gutter pipes and measuring taps. Pipes, gutter pipes. Pipes can be prepared from cast iron. Gutter pipes. Pipes can be prepared from cast iron. And measuring taps. Measuring taps is the metal which can use it for measuring taps is nickel steel. So this will be the relation. Gutter pipes is cast iron and measuring taps is what is it? Nickel steel. Measuring taps, measuring tapes. Measuring tapes, already we know that measuring tapes can be manufactured from nickel steel. So option A is 3, B is 1, C 2, C4, D2. C4, D2. So option is A is 1. Which option is right? A is 3, A3. Option 4. You should go only one and only option was there. Out of that, A is 3. Electrical resistance is copper, and B is 1. Battery is zinc, and C is 4. Cast iron, gutter pipes, and measuring tapes. D is nickel steel. So what will be the option? Means option 4 is the right answer for that question number 6. Question number 6, option 4, and next followed by that question number is 8th. This was very important question. Which of the following pair of ions may exhibit same color? Question number 8, very important. Color. Which of the following pair of ions may exhibit same color? So you should remember, same color is equals to same number of electrons. Same color is equal to same number of electrons. If we are going for option number 3, option C, suppose option 3 or option C, Fe3 plus atomic number of iron 26. Atomic number of iron 26. We know argon 18, 4s2, 20, 3d6. This was a configuration of iron 3 ferric, and Fe3 plus. Fe3 plus iron configuration 26th atomic number, argon 18, 4s2, 3d6. Fe3 plus means 23 electrons only, that is argon 18, 4s0, 3d5. So number of unpaired is equals to 5 electrons. Number of unpaired electrons is equals to 5. On other hand, Mn we know that atomic number 25, argon 18, 4s2, 3d5, and Mn2 plus configuration 23, same argon 18, 4s0, 3d5. What is number of unpaired? Number of unpaired here also 5 electrons. Same color, same number of unpaired electrons. Same number of unpaired electrons we found in iron 3 plus and manganese 2 plus. Iron 3 plus and manganese 2 plus contains same number of unpaired electrons. Same number of unpaired electrons means it will exhibit same color. D configuration 5d5 D5 configuration. Here also D5 configuration. D5 configuration are present in both examples. So for question number 8, option 3 is the right answer. Option 3 is the right answer for question number 8. Iron 3 plus and Mn2 plus. After that, next one is question number 10. This is a conceptual question. Which one of the following is the most correct statement? Brass is an interstitial alloy while steel is substitutional alloy. What is interstitial and what is substitutional? Already we know that interstitial means the vacant space. The vacant space is occupied by or some elements are trapping the elements. What are the elements? carbon, hydrogen, nitrogen, those elements are trapped, because while crystal formed, on that crystal some voids will be there. That voids are said to be interstitial compound, that voids are said to be interstitial sites. That sites can be occupied by carbon, hydrogen, nitrogen, those are said to be interstitial. Then what is substitutional? Substitutional means addition of two metals or addition of metal plus non-metal, that is expressed in the form of substitutional. So which of the following is the most correct statement means out of that four examples, once you go through that example number 2, brass is substitutional alloy while steel is an interstitial alloy, because of steel which contains carbon, because of cast iron, wrought iron, pig iron, different type of irons are there. On that all type of irons, the impurity will be there. That impurity is said to be carbon, 0.5% to 1.25% and 2 to 3%, more than 3%. According to the percentage of carbon only, we have to differentiate cast iron, wrought iron, pig iron, like that, different type of irons. So addition of one metal to another metal or metal to non-metal is called as substitution. Within the metal, within the gaps, if the metal, particular metal is there, on that metal gaps will be there, that gaps are satisfied by carbon, hydrogen, nitrogen, that is called as interstitial. So out of this from this information we have to select which statement is correct means brass is substitutional alloy while steel is an interstitial alloy. Steel is a combination of iron plus carbon. Brass, bronze, we know that brass, copper plus zinc. Copper and zinc, copper one metal, zinc one more metal, you should add that two, then we will get brass. Steel is iron plus carbon, that is interstitial. Steel is an example for interstitial, on the other hand brass is an example for substitutional alloy. So second option is right answer for the question number 10. And next question number 12. Question number 12, we know that this is already we done in class, the coinage metals. Coinage metals already we know copper, silver, gold. Copper, silver, gold are called as coinage metals. These are belongs to 1b group elements. 1b group elements are said to be coinage metals, but nowadays silver and gold are restricted to collect items. Instead of silver and gold, they can preferred copper, nickel. Copper, nickel, that is called as UK coins. So the correct answer for question number 12, concept 12 is copper, silver, gold are said to be coinage metals. After that, question number 13, very important, this is in aqueous solution, Eu2 plus and Sm2 plus ion act as. 13th question, very important, this is Eu2 plus Sm2 plus. Eu2 plus is europium, Sm2 plus is samarium. Europium and samarium both are belongs to lanthanides. And lanthanides stable oxidation number is +3. Stable oxidation state +3. Lanthanides common oxidation state and stable oxidation state is +3. But in this example, europium is +2. Samarium is +2 due to the half fill electronic configurations. And Eu2 plus is converted into Eu3 plus. On the other hand, Sm2 plus converted to Sm3 plus. Here +2 to +3. Here also +2 to +3. +2 to +3 means what we understood here, oxidation state increases. Oxidation state increases means oxidation reaction. This is oxidation reaction, this is also oxidation reaction. The species which are involving in oxidation is called as reducing agent. So what will be the right answer for this question? In aqueous solution, europium 2 plus, samarium 2 plus ions act as a strong reducing agents. Common oxidation number +3. Above +3 oxidation number act as oxidizing agents. Below +3 oxidizing agents act as reducing agents. That will be the blind information regarding lanthanides. Because of stable oxidation state or common oxidation state of lanthanides are +3 only. So europium and samarium both are act as strong reducing agents. So option number 1 is right for that question number 13. And next one is question number 15. Question number 15. This is also concept oriented question. Concept means electronic configurations. We have to thorough that electronic configurations. According to that electronic configurations only, we have to find the right answer for this. 4 successive members of the first row transition elements are listed below with their atomic numbers. Which one of them expected to have the highest third ionization enthalpy? We want 15th number, question number 15 it is. IP3 we required, IP3. Vanadium, Z is equals to 23, scandium, titanium, vanadium. What is configuration? Argon 18, 4s to 20, 3d3. This is a configuration of vanadium. Next, chromium 24, argon 18, 4s1, 3d5. Iron 26, argon 18, 4s2, 3d6. Manganese 25, argon 18, 4s2, 3d5. Then what is the question here? Which one of them is expected to have the highest third ionization enthalpy? Remove one electron from s orbital, that is said to be ionization enthalpy 1. This is general electronic configuration. What is I1? 4s1, 3d3, 4s0, 3d5, 4s1, 3d6, 4s1, 3d5. This is I1. What about I2 values? 4s0, 3d3, 4s0, 3d4, 4s0, 3d6, 4s0, 3d5. This is I2. What we have to find? Expected to have the highest third ionization enthalpies. First ionization enthalpies values are like this. Removal of one electron, removal of first electron from this, like. After second ionization enthalpy values are more for chromium, because chromium electronic configuration after removal of one electron it is 3d5 configuration. 3d5 configuration means it is more stable, extra stable due to the half filled electronic configuration. Due to the half filled electronic configuration, I2 more for chromium. After removal of second electron from that, next which is difficult to remove? Which is difficult to remove here? 3d3 configuration is it? 3d4 partial filling, 3d3 partial filling, 3d6 partial filling, 3d5 half filled configuration. 3d5 half filled configuration takes place in manganese. Manganese half filled configuration takes place. So very difficult to remove an electron. So what will be the conclusion regarding this? So conclusion regarding this means I3 more for manganese. What the reason is? Half filled electronic configuration. Half filled electronic configuration is nothing but D5 configuration. I2 more for chromium. What is configuration? D5 configuration. Half filled and full filled electronic configurations are more stable than partially filling electronic configurations. Due to this, more ionization potential, third ionization potential is maximum for manganese. So option number 4 is the right answer for that question number 15, and followed by that question number 16, very important question. 16 expected question, it is 16 for examination point of view. So what is 16? And read the concept. Which of the following is most basic? Which of the following is most basic means how to find is most basic or least basic means those are bases. Those bases are belongs to lanthanides, lanthanide hydroxides. Question number 16. LNOH taken thrice. Atomic number increases. Atomic number increases. Basic strength decreases. because these are what? Lanthanide hydroxides. For lanthanide hydroxides, M3 plus size decreases from left to right. The cation size M3 plus size decreases from left to right. Already I was given some information regarding this. Lanthanum 57, cerium 58, 57 plus 7, 64 gadolinium, 64 plus 7, 71 lutetium. So this will be the general order. Lanthanum is the first element, strong base. Next cerium, next gadolinium middle, and lutetium last. So according to the options, europium, cerium is here, samarium is not there, lutetium is here. Cerium, lutetium is last, cerium is here, samarium, europium will be here, lutetium. Lanthanum is not there. Cerium most basic. See this. So here, out of that examples, europium, cerium, samarium, lutetium, 4 elements are given. Europium, cerium, samarium, lutetium. After cerium only, because lanthanum, after lanthanum next element is cerium only. So what is basic strength means? LaOH taken thrice is greater than CeOH taken thrice, greater than what? GDOH taken thrice, greater than what? LuOH taken thrice. After cerium only next elements takes place. So here europium, cerium, samarium, lutetium. Cerium is 58, lutetium is 71. Before gadolinium 64, 63 and 62 are said to be samarium, europium. Samarium, europium, 63 and 62. So out of these 4 elements, which element is first means? First element is cerium only. Starting elements are strong bases, starting metal hydroxides. So lanthanide hydroxides basic strength from left to right, M plus 3 cation size was decreases, due to that basic strength was decreases. So remember, out of the 4 examples, cerium hydroxide is a strong base, lutetium hydroxide is a weak base. Lutetium hydroxide is weak base because of cerium is adjacent of lanthanum. Lanthanum hydroxide strong base. After lanthanum next one is cerium. So in this example cerium is there, no lanthanum is there. If lanthanum is not there means we should give the priority for cerium only. If lanthanum is there then we should give the priority for lanthanum. So option number for this question, option number 2 is right answer. Second option, cerium hydroxide is stronger or more basic. So after that next one is 18th question is important. It was a repeated question for entrance point of view. So what is 18th question? Gadolinium belongs to 4F series. Gadolinium belongs to 4F series. Its atomic number is 64. Which of the following is the correct electronic configuration of gadolinium? Question number 18. Gadolinium ZD, Z is equals to 64. I said lanthanum 57, cerium 58, gadolinium 64 and lutetium 71. Lanthanum it is 4F0 and we should write 6S1 5D2. Here 4F1 6S1 5D2. Here 4F7 6S1 5D2. Here 6S2 5D1. 6S2 5D1. And last year 4F14 6S2 5D1. So this was a configuration of the special elements the elements which are belongs to lanthanides, lanthanum 57, there is no F electrons. Configuration is 6s2 5d1. After xenon atomic number 54, 54 plus 3, 57. And after that lanthanum, next cerium, 5d configuration is there. Gadolinium, 5d configuration is there. Lutetium, 5d configuration is there. But gadolinium is 4f7 off field configuration, lutetium is 4f14 full field configuration, and lanthanum 4s0 f0 configuration. So according to this information, the correct option for that question number 18 is xenon 4f7 5d1 6s2. Xenon 4f7 5d1 6s2. So it is attached to xenon because xenon atomic number 54. So half filled electronic configuration of gadolinium. F configuration is half filled, F14 is full filled, F7 is half filled. So make a note, this was very important. This is a previous entrance point of view question. So don't neglect, you should concentrate the electronic configurations. So at least you should practice this 4 electronic configurations. Remaining all elements what there in that lanthanides, there is no 5d, 5d 0 only there, 5d 0. Remaining all configurations 4f1 to 4f14 only. Only these 4 are the exceptions, only these 4 are the exceptions. So you should make a note, the correct option is the first option for the question number 18. For the question number 18 is first answer is right. So after that next question number is 24. It is a direct conceptual question. Blood hemoglobin contains the metal is iron. This is a direct question. Blood contains blood hemoglobin. Hemoglobin contains which transition element means iron, and in chlorophyll the element is magnesium. Aluminum is not belongs to transition element. Copper belongs to transition element. So here option number 2 belongs to chlorophyll, and option number 4 belongs to hemoglobin. Hemoglobin contains the metal is iron. After that, chemical formula of rust. This is also a conceptual question. Question number 25. Chemical formula of rust. This is you have to make a note. Fe2O3 XH2O. Chemical formula of rust. How rust will form means Fe iron kept in oxygen. Iron plus air. Simply iron plus air gives rise to rust. What is rust means? Fe2O3 dot XH2O. This is also a conceptual question. Simply it is iron of ferric oxide. Ferric oxide with hydrate, hydrates with water molecules. Ferric oxide is named as rust. So rust composition is Fe2O3 XH2O. Fe2O3 XH2O is a rust configuration. After that question next after 25th. So option for this option is third option is right answer for question number 25. And the next now question number 26th. Question number 26th. Question number 26 in which 5F subshell is half filled. This is important. Question number 26, 5F subshell. 5F subshell is half filled. 5F means you remember the example is actinides. It is 5F is actinides, and in for this actinides already we discussed this point in synopsis and in theory class. 89 actinium, 90 thorium, 91 protoactinium, 92 uranium, and 93 neptunium, and 94 plutonium. After 94 next one is 95, 96 are these only. 95 is americium and 96 is the curium. 95 is americium, 96 is the curium. These two configurations, and here thorium and actinium does not contain F electrons. Thorium F electrons 0, actinium also F electrons 0. After thorium next F configuration starts from protoactinium. Protoactinium, uranium, neptunium 1, 2, 3, 4. Here off-field configuration will get 7. 7 means it is a 5F 7, 7s2. This is a configuration. 5f7, 7s2 configuration takes place in americium and curium. This will be the special property of americium and curium, abnormal electronic configurations. Remaining are not half filled and not full filled it is. So this is a theory oriented, so you should read that concept, then you will get idea about this. Americium and curium, the 5f subshells are half filled. Remaining what the elements are was given, berkelium was given, different elements was given, those elements are does not follow that half filled electronic configuration of 5f shell. So you should blindly revise this. Americium and curium is examples of half filled 5f configurations. So the question number 26 answer 1 is right for that, and the next one is question number 27. 28. Question number 28. Question number 28. This is a simple question. The metal having highest melting point is tungsten. We know that. Metal having highest melting point is tungsten. Simple. We know that. And the next number, question number 29. Question number 29 was important. Question number 29. Question number 29. Which of the following ion is paramagnetic? Which of the following ion is paramagnetic? Option 1 was given 29. Option 1 La3 plus 57. Option 2 Lu3 plus 71. Yb2 plus 70. Sm3 plus 62. Already we know that lanthanum 3 plus, what is configuration? Xenon 5d1 6s2, xenon 4f0 5d1 6s2. While removing 3 electrons from this, what will you get the configuration? 4f0 5d0 6s0. Lanthanum 3 plus, what is the configuration of lanthanum 3 plus? Means all it is noble gas configuration. Lanthanum 3 plus is an example for noble gas configuration. And next to lutetium 3 plus, if you are going to lutetium 3 plus, Xc xenon 4f14 5d1 6s2. Lutetium 3 plus, removal of 1 electron from 5d configuration, removal of 2 electrons from 6s configuration, then this is fulfilled configuration. Fulfilled configuration of lutetium. Fulfilled configuration of lutetium, this is also stable electronic configuration. There is no unpaired electrons, so it is not a paramagnetic substance. And while coming to the ytterbium 2 plus, configuration xenon 54 4f14 6s2. So this is the configuration of ytterbium 2 plus. Removal of 2 electrons from this, here also we will get stable electronic configuration. For this, what is configuration? 4f14. For this, what configuration? 4f14. For this, what is configuration? 4f0. 4f0 configurations, 4f14 configurations are diamagnetic substances. Unpaired F electrons are there, those are considered as paramagnetic substances. If you are going to the samarium 3 plus, is what? Xenon 54 and 4f 6s2, 54 plus 2 56, 56 plus 6 62. So this is a configuration of samarium. Samarium configuration is xenon 54 6s2 4f6. Removal of 3 electrons from this, what we will get? 4f5 6s0. 4f5 6s0 configuration is sm3 plus. This is yb2 plus. It is lu3 plus. It is La3 plus. La3 plus, Lu3 plus, Yb2 plus are stable electronic configurations. F0 and F14 configurations doesn't exhibit a magnetic property, that is diamagnetic substances, except samarium 3 plus. Samarium 3 plus is paramagnetic substance due to the presence of unpaired F electrons. Unpaired F electrons takes place in this example. Due to this, samarium 5 plus, samarium 3 plus is paramagnetic substance out of that examples. So option is Fourth option is the right answer for the question number 29. After that, question number next is 33. 33. After that, question number 33, which of the following set of elements do not possess F electrons? This is very important. Do not possess F electrons, very important. If you remember, one is thorium, fixed, one is actinium, second one is lanthanum. These are the examples: lanthanum, thorium, actinium. Lanthanum 57, actinium 89 and thorium 90. These are the atomic numbers of these elements. Thorium doesn't contain F electrons, actinium also 4F, 5F0, lanthanum also 4F0. So 4F0, 5F0, 5F0 configuration. So remember, my dear students, here this configuration is 4F0, 5D1, 6S2 here, 5F0, 6D1, 7S2 here, 5F0, 6D2, 7S2. This was the configuration of actinides and lanthanides except thorium and actinium and lanthanum. Thorium, actinium, lanthanum. These three elements does not possess F electrons. F electrons are absent. Thorium is very important. Thorium belongs to F block, but these two are not belongs to F block. After lanthanum, next is lanthanides. After actinium, next are actinides. But thorium belongs to F block, but absence of F electrons. 5F0, 6D2 and 7S2 configuration. So answer is lanthanum, thorium. Where it is answer? Option 3 is the right answer. Lanthanum, actinium, thorium. Lanthanum, actinium, thorium is the right answer for the question number 33. And after that, next one is question number 34. The atomic number of vanadium, chromium, manganese, iron are respectively 23, 24, 25, 26. Which one of these may be expected to have the highest second ionization enthalpy? Already we discussed this one. Highest second ionization enthalpy is for chromium only. Third ionization enthalpy is for manganese. In previous question, we 2-3 questions back we discussed this one. 23, 24, 25, 26. Vanadium, chromium, manganese, iron. Question number 34. Vanadium, chromium, manganese, iron. 23, 24, 25, 26. Argon is common for all. Argon 4s2 3d3, 4s1 3d5, 4s2 3d5, 4s2 3d6. Highest second ionization enthalpy. First IP value already we know. What is first IP value? 4s1 3d3, 4s0 3d5, 4s1 3d5, 4s1 3d6. This is I1. I2 value is more for chromium. I2 value is more for chromium because why I2 value is more for chromium means stable electronic configuration, 3d5 electronic configuration. It is a risk to remove an electron from outermost configuration from chromium. Due to that, chromium second IP value is more. So option is second is the right answer for the question number 34. Question number 34 answer is second one is the right answer, and the next one is question number 35. Question number 35, on addition of small amount of KMnO4 to concentrated sulfuric acid, a greeny oily compound is obtained which is highly explosive in nature. Identify the compound from the following. Already we studied in theory classes regarding this. Manganese forms different type of oxides. On that oxides, one and only oxide is greeny oil. Green oil. What is that green oil oxide? Is Mn2O7. Mn2O7 is the green oily compound which is highly explosive. Because of reaction takes place is in between KMnO4 versus H2SO4, we will get Mn2O7, KHSO4 and H2O. Mn2O7, KHSO4 and H2O. Mn2O7, KHSO4 plus H2O takes place when reaction is in between KMnO4 versus sulfuric acid. KMnO4 versus sulfuric acid. This was a reaction. When reaction takes place 2KMnO4, 2K. So this was a reaction. So from this reaction, this is a reaction. So this is from this reaction, 2 KMnO4 plus H2SO4 gives rise to Mn2O7 plus KHSO4 plus H2O. So while potassium permanganate is combined with sulfuric acid, we will get this is a green oil, green oily explosive. Green oily explosive, it is acidic oxide, it is. This is acidic oxide, this is a manganese oxide, heptoxide, it is 7 oxide. So answer is right answer for that question number 35 is first option is right. Where you found green oil? Green oil means that is Mn2O7 only. Mn2O7 is the right answer for that question number 35. After that, question number 36. Which of the following shows highest magnetic moment? Highest magnetic moment, what is the condition? Highest magnetic moment means maximum number of unpaired electrons. Maximum number of unpaired electrons, highest magnetic moment. Less number of unpaired electrons, least magnetic moment. Highest magnetic moment, we required maximum number of unpaired electrons. So here options, we should go to options. Number 1 is V3 plus, vanadium 3 plus, chromium 3 plus, iron 3 plus, cobalt 3 plus. Vanadium 23, 24, 26, 27. These are the atomic numbers. We know the electronic configurations. Argon is common for all. 4s2 3d3, 4s1 3d5, 4s2 3d6, 4s2 3d7. These are the electronic configurations of vanadium, chromium, iron, cobalt. Then what is this is metal configuration. Then what is metal plus 3 configuration? M plus 3 configuration is 4s0 3d2, 4s0 3d3, 4s0 3d5, 4s0 3d6. This is the M plus 3 configuration. How many unpaired electrons here? N is equals to 2 electrons, N is equals to 3 electrons, N is equals to 5 electrons, and in this one N is equals to 4 electrons. So we know to calculate magnetic momentum is mu is equals to, one formula was root over n into n plus 2 Bohr magnetines. So n value is more for iron 3 plus, n value is more because of the configuration. Iron 3 plus is 4s0 3d5. 4s0 3d5 means the number of unpaired electrons are more. 5 unpaired electrons are present in iron 3 plus. Due to that reason, which is showing highest magnetic moment means iron 3 plus shows highest magnetic momentum. Highest magnetic moment or highest magnetic momentum was shown by iron 3 plus due to D5 configuration. D2 configuration, D3 configuration, D5 configuration, D6 configuration. D6 configuration means one pair electron, remaining 4 are the unpaired electrons. So correct option for question number 36 is third option. After question number 36, next one is question number 37, not there. Question number 40. Question number 40, an example of disproportionation reaction. Disproportionation reaction, we know that reaction takes place both oxidation reaction as well as reduction reaction. Both oxidation as well as reduction reaction takes place. That type of reaction is called as disproportionation reaction. And here, which is a right option for that means once you go through that option number 2, CuBr gives rise to CuBr2 plus Cu. CuBr gives rise to CuBr2 plus Cu. This is an example for disproportionation. Because of Br minus 1 means copper plus 1 here. Here copper 0, here copper plus 2. Plus 1 to plus 2 increases, plus 1 to 0 decreases. Both oxidation as well as reduction takes place. This is an example for redox reaction. Single element which undergoes oxidation as well as reduction. The oxidation state of reactant is an intermediate of the oxidation states of the products. So this is an example for disproportionation reaction. So second option is the right answer for the question number 40. Question number 40, the right option is the second one. 2CuBr gives rise to CuBr2 plus Cu. Instead of that, they should write like this: Cu plus gives rise to Cu2 plus Cu. This is also right without Br. Cu plus plus, Cu plus gives rise to Cu2 plus plus Cu, Cu2 plus plus Cu, 2Cu plus, 2Cu plus gives rise to Cu2 plus plus Cu is an example for a disproportionation reaction which undergoes, same element undergoes oxidation as well as reduction. So this is a question number 40, disproportionation reaction. After that, question number percentage of carbon in steel is, this you make a note, my dear students, this question, percentage of carbon in steel is, simple, it is 0.2 to 1.5 percentage, 0.2 to 1.5 percentage. Third option you make a note regarding this reaction, this question, because it is an example for interstitial compound, iron which contains carbon. Carbon percentage is 0.2 to 1.5% is said to be steel. So option 3 is the right answer for that question number 42. So after that, question number next is a 45, 43, 46. Question number 46. What would happen when a solution of potassium chromate is treated with excess of dilute nitric acid? What would happen when a solution of potassium chromate is treated with an excess of dilute nitric acid? This is question number 46. So here what the reaction takes place, K2Cr2O7 potassium dichromate and HNO3 gives rise to what we will get, K2CrO4 KNO3 plus H2O, K2CrO4 and KNO3 plus H2O, K2CrO4 plus KNO3 plus H2O. This was a reaction. K2Cr2O7. What happens when a solution of potassium chromate? Potassium chromate is treated with an excess of dilute nitric acid. Chromate means here K2CrO4. K2CrO4, it is K2Cr2O7. Because of chromate and dichromate, already we done in class it is. Chromate and dichromate both are interconvertible. Chromate and dichromate both are interconvertible here, and what we will get means chromate formula Cr2O4 minus 2 on adding of acid, addition of acid to chromate, it becomes Cr2O7 2 minus dichromate, addition of base to dichromate becomes acid. Both chromate and interchromates are invertible on the basis of pH value. They should maintain the pH is nearly 3 to 4 pH. It is between the 3 to 4 pH. Chromate and dichromate are interconvertible. Acidic solution of chromate is addition of acid to chromate, we will get dichromate. Addition of base to dichromate, we will get chromate. So on that equation, once you observe that option number 2, Cr2O7 2 minus and H2O are formed. Cr2O7 2 minus and H2O, K2Cr2O7 and H2O. Cr2O7 2 minus and H2O are formed when dilute nitric acid is added to the potassium chromate. If same you should add potassium dichromate, you should add base, then we will get chromate. So that is a interconvertible chromate and dichromate. So option number second is the right answer for that question number 46. You should go through that option number 2, and so this was end of the session, and still we required one more class to discuss some more questions regarding D and F block elements. So stay with us, stay safe. I hope you understood. All the best. Thank you.